Alrighty, welcome back. I'm tired. I'm sore. I have this online virtual trainer. He has been absolutely just crushing my legs. So I ran this morning, and let me tell you, my legs felt like they weighed 45,000 pounds. But good news is I got a percolator from Amazon, and I ordered a Starbucks blonde roast. Oh, wow, let me tell you, I can make a coffee. So if you ever want me to ship you coffee, just let me know. I will charge a lot for shipping, but I can make you a nice cup of coffee. Anyways, we're going to get the piecewise functions today, and this is our last section on, the family of functions packet. Again, I'm going to keep this as simple as possible just because with graphing, with technology, if you guys had iPads and the pen I have, I make you guys graph, but you don't. You just have laptops, so it's pretty tough to graph and show all your work and show me that stuff. So you'll have another four or five question multiple choice classwork on this, just kind of matching up graphs and stuff. But piecewise functions are tough to explain verbally, so I'm just going to kind of go ahead and I'm going to start graphing number 1. And you're going to notice it says f of x equals x plus 5 for when x is less than or equal to 2. And it says f of x equals 1 when x is greater than or equal to 2. First things first, let's just take a look at this f of x equals 1. All that means is f of x is the same thing as saying y equals. So we just have the line y equals 1, which is a correct, very good, Anthony, a horizontal line. See, I knew you were going to call that answer, Ant. You just guys being guys. I get it. So it's a horizontal line. All right, so we're going to graph these two functions. Then I'm going to show you what this x is less than negative 2 and x is greater than or equal to negative 2 mean. So first, let's start with x plus 5. Now, the line x plus 5, it's a linear graph. It's a straight line. So on my graph here, oh, wow. There's a lot going on here. This is my origin, so I'm going to go up 5 because it's x plus 5. My y-intercept is 5. So 1, 2, 3. Holy goodness gracious, what just happened? Oh, my God. Stinking iPad. Gosh darn it. God. They don't make these things easy, do they? Nope, that's not it. That's not it. Ooh, here we go. All right, sorry about that. So 1, 2, 3, 4, and 5. And now it's x plus 5, so we just go up 1 over 1. La 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 la. La da da da. I'll pull out my handy dandy ruler. Make a nice straight line. And we will be rocking and rolling here. Oh, that's what the heck? This stinking iPad. All right. Oh, wow, that's a nice line. Okay. And, all right, goodbye, ruler. Now I'll graph the function y equals 1. So I'll just draw a horizontal line at y equals 1. So I'll get my ruler back out. And boom. I will graph. And like I said, anytime during this video you just need to fast forward, zoom ahead, please, by all means, go for it. I won't judge you. Maybe. Just kidding. No, I won't judge you. Boom. All right. There we go. I'll draw my arrows on this. So I know this goes on forever in both directions. Oop, that's not what I wanted to do. Bada bing and bada boom. All right. So let me also just pull out my eraser now. Pixel eraser. Very good. Thank you. All right, so those are my two lines. Pretty straightforward graphing those. Now I have, for the line x plus 5, which is the blue graph, I have x is less than or equal to 2. Now what that means is we only want this graph for the x values that are less than negative 2. So that's all we're looking at right here. Didn't mean to do that. So we want the x values that are less than negative 2. So now here's our x-axis. Pull out my yellow. So that's the origin right there. If you see my little yellow mark, it's negative 1. This is the x value of negative 2. So what this is saying is that this piecewise function, they only want the graph from x equals negative 2 and all numbers less than. So negative 3, negative 4, negative 5. That means we just want the graph from this part right here, where I put my yellow point, and everything else to the left of it. Everything else down here where the blue is. So what we're going to do is really just erase the top part, because this graph is only concerned about the line x plus 5 when x is less than negative 2. So I'll get my eraser, and I'm just going to simply erase everything from x is less than negative 2. Now, you'll see I also erased that dot right there. So think about this. If I were to say, hey, Joe, give me numbers that are less than negative 2. You would list negative 3, negative 4, negative 30, 50, but you wouldn't tell me negative 2 because x is not, negative 2 is not less than negative 2. It's equal to it, but it's not less than. So for that case, we're going to put an open circle right here on negative 2. So that's my x on negative. We have an open circle. Sound good? Now, I have over here, for my line equals 1, x is greater than or equal to negative 2. So that means that on my red graph now, I want all the x values that are greater than or equal to negative 2. So I'll get my eraser back out. This is negative 2. So I want all the x values greater than. So what that means is I only want this graph from this point right here all the way to the right, because all these numbers going on to the right in the x direction are all numbers that are greater than negative 2. So what that means now is I am going to erase the left side of my graph because I really don't want it. I don't need it because this piecewise function only wants the graph when x is greater than or equal to negative 2. Now, when we have a greater than or equal to sign, we have a closed dot right here. We have a closed dot right here. And right now, that is what a piecewise function looks like. I'll zoom in a little bit. That's our first example of a piecewise function. You're probably just like, wow, what did this man just talk about for the past 8 minutes? That's okay. The concept, it's a tough thing to kind of grasp a little bit. It's weird, it's new, but you will need this going forward. So, like I said, we're not going to spend too much time on this. You have the classwork after, then boom, we're done. Sound good? I'm going to go over one more problem, then I'll let you guys go. Try the classwork. I'll fill in the rest of these notes for you too, so you have some examples to look at. Like I said, the class will be very straightforward. Sound good? Aight. Let's take a look at another one. Let's take a look at, gosh, I hate when this does that. Let's take a look at, not that one. All right, number 5. Number 5 looks like a good one. So I have the function f of x equals x squared for when x is less than or equal to 0. And I have the function negative x squared for when x is greater than 0. So first, I'm just going to start by graphing our typical function x squared. And for those of you who remember, it's a U-shaped, it's a parabola. So I have 1, 1, negative 1, 1, because when I plug in 1 for x squared, I get 1 for my y. So when x is 2, that is 2 squared, so 4. So 2, 1, 2, 3, 4. Same thing here. All right, that's good enough. La-da-da-da. Alrighty. That's my function. X squared. Now I'm going to graph the function negative x squared plus 4. So, now, negative x squared plus 4. So let's think about that going back. The negative means that my graph is going to be flipped upside down. The plus 4 means my vertex starts at a y-intercept of 4. So 1, 2, 3, 4. And it's the same thing. I go down 1, left 1, down 1, right 1. I go left 2, down 4, because negative 2 squared is 4. 1, 2, 3, 4. And then right here. So don't worry about too much how I'm graphing these. The main part is when we get into the domain values. And I'll just graph that. Bada bing, bada boom. Draw my arrows. Terrible arrow there, but we got the idea. All right, word. So now I have, for x squared, which is my blue graph, I want all the graph when x is less than or equal to 0. So here's 0 right here. I just put my little red dots. That means I want all the x values when x is less than or equal to 0. So I want just the left side of the graph, because that's all the negative x numbers. Those negative x numbers are less than 0. So what I'm going to do is erase the right side of my graph. Get rid of all that blue. And boom. And now I want a solid blue circle on 0 because it's x is less than or equal to 0. So I have a solid dot. Now, for negative x squared plus 4, that domain value, as you can see right here, is x is greater than 0. So I want all of this red graph when x is greater than 0. So that means I want all of the x values on the right side because all of the positive x values will be greater than 0. So I'm just going to erase now the left side of my graph for my red one. Get rid of all that. Whoop. And then good. Now, x is greater than 0, excuse me. So at the point when my x value is 0, it needs to be an open circle. Because when you have x is greater than 0, it has no little line underneath the inequality sign, so you have an open circle. So this is what this graph would look like right here for a piecewise function. Yes, a little weird, a little different, but hey, we're getting into some in-depth content right now with algebra, so it's gonna get a little bit more abstract, less concrete. But don't worry, you got this. Be good. I don't have lemon protein bars anymore. I got some chocolate ones, so business is booming. Alrighty, I'll post a classwork. It'll be to the point, simple. Check out these notes as I'm gonna have them all filled out for you, and